And this presentation is going to be about rack management, but with an emphasis on managing AI infrastructure. So rack management's been around for a number of years, but Han and I believe that AI infrastructure is completely changing the game here, and it's going to require some significant changes to how we look at a rack manager. Before we get into what the changes are though and where the challenges are, I want to quickly just go over what Rack Manager is for those of you that may not know. Rack Manager is something that would typically sit in each rack and manage that rack. It would talk up to your data center management software, and it would talk down to all of your nodes, whether that be the BMC or other devices in the rack. So it's responsible for managing all of the infrastructure in the rack, which again with AI infrastructure will grow. It simplifies management because it becomes a single point of discovery. It increases scale of management. If you can manage a row manager or a rack manager from your data center manager, then that multiplies the number of nodes if you're struggling with your data center manager to reach tens or hundreds of thousands of servers out there. Obviously, it enables group operations and adds levels of aggregation, as I just mentioned. And it can improve your security too, because below the rack manager, you can create like virtual LANs or whatever so that the nodes themselves, if your BMC security is not where it needs to be, can be isolated from the rest of the network. The next issue of Rack Manager is where it sits. We work with a lot of different customers. A lot of these customers choose different areas to put this Rack Manager. Some might want to put it in their Tor management switch, either within like the Sonic layer if they're using Sonic, or as a hardware RMC attached to it. Others might want to put it in a power shelf, and then what's commonly referred to as a PMC, especially if it's doing mostly power management capabilities. But what we're seeing again with AI is more and more need for a dedicated rack manager. And in fact, you kind of almost move from firmware in this case, where you might be just running this on a dual core ARM, to needing actual, an x86 or a higher end ARM server to run all this in. So there's lots of different places. We believe in an open mindset, maybe not all the way down to open source, but at least having allowing the OCP vendors to build a solution with the functionality I mentioned in the previous slide, with the hardware silicon in this slide, so that we can, that they can build the product that meets their needs. There is a OpenRMC subproject I just want to quickly mention. It's actually run by Han here. And it's been traditionally designed to focus on kind of northbound interfaces to the rack manager. It does have some software and hardware contributions, but the OpenRMC is not prescriptive to either hardware or software. And it's historically focused on traditional rack management, but that's something we hope is changing based on this presentation and the needs going into the future. Okay, so the next two slides before we hand it over to Han is we're going to start discussing now getting into the AI problem, AI infrastructure. What happens with AI infrastructure and why it presents a problem to your traditional rack manager. I'll cover the first slide, Han will get the second, and then he's going to talk a little bit more about how Meta sees this specifically for them. So the first problem is these are mostly obvious, but maybe the solution isn't so much. Much higher single rack density with intelligent components. So all sorts of new components added to this. You now have cooling, liquid cooling perhaps, so you have CDUs. You might have PCI switches, NB switches, CLX switches, whatever, power shelves, smart NICs, and of course the GPU. So all of these create problems by themselves, because if they're all carrying data, they're all carrying water, they're all carrying power, and if any of those become a problem, the node itself is going to stop functioning. And so, just simple things like powering on a node. Used to be you'd send an IPMI command or a Redfish command to the node, you power it on. Now you got to make sure it's got sufficient cooling. You got to make sure it's got sufficient power. If it's disaggregated, you got to make sure it's composed correctly before you power it on. So there's a lot more to think about even on the most simple tasks that a rack manager might do. And of course, with more intelligent components comes more firmware. I've been in this industry a long time, but we used to measure a BIOS in kilobytes, and maybe you didn't have a BMC. Now, firmware updates consume hundreds of megabytes of flash that you have to coordinate against all of these smart components. And if you get any of them wrong, you can cause problems and be disruptive if you don't follow a best known configuration. The next big challenge is cooling and power. I mean, I think you can see out in the show floor the number of just liquid cooling boosts that they're talking about. I think I read something the other day that up to maybe 40% of data centers will have some form of liquid cooling by 2026. So liquid cooling presents more rack challenges. Leak detection, and if a leak happens at a node, what do you do about the other nodes in that rack? How do you solve that problem? Peak power, the addition of GPUs greatly grows the amount of power. Traditional power management technologies that just look at the CPU, whether it be Intel's Node Manager or AMD's APML libraries, that will cut your power to the CPU, but that doesn't cover the GPU. So you got to figure that out. You got to decide whether you're going to assign the workload to the power envelope or change the power envelope to manage the workload. Two different ways of thinking about it. So again, power and thermal challenges. And then finally, we have to think about health. AI infrastructure typically runs under like an HPC infrastructure, which is typically done with parallel processing, which means if you have one GPU go bad or one node go bad, the entire solution could go down. I was talking to a friend the other day, and he said they look at things at 20-minute intervals every time they check the health. They can roll back 20 minutes. But AI infrastructure is so expensive, and it's such an OpEx and a CapEx cost that even 20 minutes of time is too much of an expense for companies to be paying. So we need to have smart, I hate to use AI twice here, but we almost need to have AI figuring out our AI infrastructure. So we need to hopefully build these into our rack management. I'm going to turn it over to Han now for the second set of challenges.
Thank you, Brian. So, hello everyone. Good afternoon. I'm very glad to be here. So, a little bit about me. So, I'm with Meta Infra team. Basically, focus on the DC Infra system architect and also the future technology exploring. So, regarding the difference of the AI infrastructure, I think one of the difference with AI infrastructure is the size of single workload, typically for a large model. So when we talk about single workload, we are not just talking about a single rack or multiple rack. We are talking about a huge giant workload might expand to the whole DC or cross DC or multiple DC. So this brings the challenge is if anything wrong with the workload, partial or small portion, then we'll tie the entire fleet down. So in that case, we have a huge workload recovery to be done, and we have to do lots of migration for the workload to coming back. So for this kind of scale, so the other one very crucial is ensure the workload for every component. We need to have a same time synchronization, cross workload, even cross multiple data center. So when the fleet has more and more GPU or accelerator inside, so there's definitely a huge surge of the manageability telemetry generated, which needed to be parsed, analyzed, and managed. So when we talk about AI infra, we obviously, AI infra is so expensive. Actually, we are not just talking about a one-time fixed CapEx invest. We are talking about during the runtime, how can we maximize the usage? So this is related relative to try to minimize the interruption rate, maximize the usage, prevent failure as much as possible. So the both CapEx and OpEx efficiency will be maximized. Okay, so this drives the requirements. Then we need a match for multiple rack to even to push to multi-layer aggregation, and we also need some management decision to be made very close to rack. Imagine this low-level fine granularity management. If we push to the DC manager, so tons of the traffic, response time, Centralized controlization will put lots of risk. So we have to push to the edge side, get close to the rack. So clearly the rack management will be the best fit. But still we see lots of challenges. So the challenge actually evolves with the model. As we see in 2003, we have the Llama 2. This year we have the Llama 3. So for future coming years, we're gonna have the Lava Next or Next. Definitely the feature getting enriched dramatically, but you can see the size going much more bigger. So in terms of the AI model size going bigger, so the whole AI clustering, the size as today and pretty much end of 2024, in next 5 years, in terms of number of connected accelerator, we will see by the 2030, the size will go 10x, maybe more. So this looks very exciting, but could be very scary if we don't manage properly. So this is experience from Meta AI Info. So this is a Llama 3 clustering. So the pie chart demonstrate our interruption distribution among all kinds of the failure. So you can see we have so many failures. So among them, roughly more than 75% of the interruption is caused by hardware issue. So for Llama 3, the scale is still like tens of thousands accelerator. So when we go to the next gen of the model, the fleet, so we can might reach hundreds of thousands accelerator, maybe later to a million scale or multi-million scale. So this will be more and more outstanding. If we cannot management properly, we will be facing a big disaster. Okay, so this try to our goal to redefine the recommendation goal. So there's a 4 category we have to address. So the first one is reliability management. So reliability now is one of the most critical things we have to deal with the AI info. So we want to make sure everything, the fleet is reliable enough to not compromise performance. We want to minimize interruption. So the second one is scalability management. So we do see more and more demand, heavy demand gonna additionally be added on. So we need to make sure we can scale further to adaptive to all this huge heavy demand. So the third one is heterogeneous management. So we need to ensure the infra will be able to handle from diverse devices, different architecture, even for the different data source, type of data source. I think the last one is performance at scale management. So we need to ensure to optimize huge scale performance without any compromising. So from Meta perspective, so we are proposing some visioning some future feature, and also we are working on this. So I think the high level philosophy for this kind of management is, so we want to convert from passive management to a very proactive, intelligent management. So the legacy management typically is like doing in-house log, do the power firmware control, pulling all kinds of telemetry. So which is not enough for the AI info. So we can't depend, so we want something or predict it. We can't wait until some failure already happened, then we start to mitigate it. It's too late. We want parsing the telemetry, get everything predicted, so we can know temperature, power, traffic. We know in advance. We know the failure gonna happen in maybe 1 week or 2 weeks, so we can mitigate, migrate work job. So this is the second stage. For workload scale way beyond maybe cross data centers. So we want furthermore. So basically, we want automatic intelligent management can perform optimization and decision. So the intelligent management will tie to the workload and the existing coming workload to address the power optimization. So what kind of workload, what time here's the fleet will cause what kind of component stress level to exactly which level, and also the time series, what will happen, and what kind of issue of failure will happen in a row. So in terms of the workload, the detail operation with very detailed timing, we will know the real time, what kind of traffic will be generated. And if we have some coming workload on top of existing workload, what kind of thermal condition it will trigger, and how can we handle it in a more intelligent way? So something like security enhancement, also the fabric network management, also heterogeneous system optimization. In other words, so basically we are changing our management philosophy from a passive to a proactive one. So yeah, so that's pretty much, so call to action. I do see this very good opportunity to address from a really huge scale, but you still look at a very fine granularity implementation. So I think it's a good opportunity to think about right now is a co-design of a new type of BMC with RMC. So also we are very eager to develop the new intelligent management design. So at this point, I think for now we need to think and design for really big. So we are solving the real AI infra challenge, but looking at small sense, but handle big sense. So this is very critical in our design philosophy. So I think the last item is, so please join the project and also reach to us to propose, discuss, and help us to address all this problem. Yeah, that's pretty much I have. Thank you.
Any questions?
Question?
Quick question. Yeah. So from using a rack management controller, right? How can he monitor the performance? It's out of band. It doesn't have a really visibility into what's going on in the workload, right?
Yeah. So right now the outbound management is still pending on BMC to pull with a very large granularity. For example, even for the outbound for the DC manager to pull, the granularity might be minutes or at least a couple seconds. For some detailed component, so this granularity is not enough, right? So that's why I said we do see right now the infrastructure limited over management because some type of legacy design, because we are dealing legacy workload, focus on a single node or something. So as we know, BMC can easily stress out and down response. So if we paint in current BMC architecture to address, no matter acting as a telemetry collector or do some type of offload engine, this is not sufficient enough. I know there's a hurdle here, so that's why I said call to action. So we probably need to think about something.
Mm-hmm.
So we want to convert a traditional BMC to something really not only for the aggressive telemetry collector, maybe you can have actual capability to perform some offload management intelligent engine work.
Yep.
Or we can make some balance from cost structure. Do we want to burden this design or push something to the recommendation side? Because recommendation side is relative financial friendly and lots of flexibility. So there's lots of open space to think about, and we don't have to tie to one rack. Physical rack has definitely one-to-one RMC to sit on that rack. We can have multiple racks to tie to.
Yep.
It's depending how much cost you want to invest on the rack manager controller. Yeah.
Thank you.
So, thank you.
I think we're out of time, so I'll give it to the next presenter.
Thank you.